So properties. So there are 6 properties. 6 properties. So if we have 2 limits that approach the same exact number, but are from different functions, and we get one limit for one, and we get one limit for the other, right? Well, there's six properties we're going to talk about today. One is called the scalar multiple. So if you have a function, if you have something in front of a function, multiplying times it, you can find the limit of the function and then multiply there. Okay? That one we won't use a lot. That one's not really used that much. The ones that are used the mostly are sum and difference. So if you're adding or subtracting 2 functions and they both approach the same number, you find the limit of each, add or subtract them together, you're done. Same thing with multiplication. You find the limit of one, you find the limit of the other, multiply them together. As long as they approach the same value, you could just multiply your answers together. Okay? Same thing with division. You can divide them. Okay? Provided that the bottom's not 0. Provided that the limit isn't 0. If the limit is 0, then the overall limit wouldn't exist, right? Okay? Power. If you have a power, you can find the limit of the function and then do the power later. Okay? And then the last one's composition of functions. Composition of functions means when you're putting 2 functions together, not using, you're literally putting one function in another. Okay? So that's the one that'll be a little bit new. So like if you have like this here. So if you have the limit of f of g of x, okay, so g is inside of f. You're just going to do one at a time. We start with the inside, so we're going to do the limit as x approaches this for g. That'll go here. And then you're going to find the answer of f, whatever it is. Okay? It looks a lot more complicated than it is. Today really isn't that bad. Let me just jump into some examples and show you. Okay? So here we go. So they give us, they say the limit for f of x as x approaches a is -3. I have no idea what a is. I have no idea what f of x looks like. But they told me what the answer is. They said the limit's going to be -3. X, so I'm still approaching a. For g of x, a separate function, the answer is 0. And then the last function, h of x, as x approaches a, is going to be +8. Okay? So I don't know what f, g, and h are. I don't have a picture of them. I don't have a graph. Sometimes they'll give you graphs, sometimes they won't. I just know the answer. Okay? I know the limit of f at a is -3. The limit of g of a at g at a is 0, and the limit for h at a is 8. Okay? So now they want us to find the limit as x approaches a for f of x plus g of x, for h of x. So this is how we're going to do it. This one falls under the sum and difference. The sum and difference. So I'm going to split them apart. So first thing I'm going to do is I'm going to find the limit as x approaches a for f of x. Put the a there. Should have put the a there. There we go. Plus, since it's a plus problem, since it's an addition problem, okay? So I separate them like that. I know that the limit as x approaches a for f is -3. So this guy here is going to be -3 plus, and then I know the limit as x approaches a for h of x, they tell me that's +8. Those are the limits individually. Add them together. -3 plus 8, +5. So the overall limit is +5. Okay? That's the addition. We do the same thing for subtraction. If that was subtraction, we would do the same thing. The only difference is instead of adding -3 and 8, we would just subtract them. Okay. So now let's do the second one. You see there's a power there, right? Well, the power property for limits says find the limit. Don't worry about the power right now. Just find the regular limit. And then whatever answer you get, then do the power, right? That's what that says. Find the limit and then do the power afterwards. So that's what we're going to do. So yeah, so we're going to find this limit first. And according to, it's going to be -3, right? According to our answers, it's -3. Now we're going to bring in the squared. So we get +9, right? Yeah, just like that. Okay. It squares it, yeah. No, yeah. You're good. No, yeah, you're good. Okay. So now the third one, C. Now look at any of the properties. Is there any properties that has a root there? Or any of the properties involve a root? No, right? So none of them involve a root. So we can't use a root property. What are our other options? Is there something we can do with that third root that we could use one of the properties? Go. So how would we write it as a power? What power would it be?
Negative?
Not negative.
Fraction?
Fraction, right? So remember, so for a math 3, so remember, if you have a root, you can write it as a fraction power. So x is to the first power, power goes on top, bottom is the root, right? So if it was x squared to the fourth power, it would be x2/4, which would then go to 1/2, right? Remember that? That's how fraction powers work, right? The top is the power, the bottom is the root. That's how we're going to do this guy, okay? So let's go back to this guy here. So I'm going to rewrite it, the limit as x approaches a, but instead of a root, I'm going to put a power. What power? 1/3. So now I'm going to do it like I did b. Just treat it as a power. So just first thing I'm going to do is I'm going to find the limit for h of x at a. According to the directions, it says it's 8, right? And then I'm going to go 8 to the 1/3 power. What is 8 to the 1/3 power? In other words, what is the cube root of 8? What number 3 times will make me 8? 2. That's what cube root means. What number times itself 3 times makes the number on the inside? Okay. Letter D, 1, so it's a fraction. We do have a quotient, right? We do have a quotient. So there's actually 2 ways to do letter D. One is using the quotient rule. One is using the power rule. So let me start with the power rule. Power rule moves this guy up front, up top. To do that, what would I have to use as a power? Negative. What power would this guy get? F of x. -1 power, right? -1 power either moves it to the top if it's on the bottom, or vice versa, moves it to the bottom. That's one way to do it. The other way is using the quotient. I'll show you after I do it this way. So the limit as x approaches a for f of x, we know that is -3, right? And then, so what is -3 to the -1 power?
Positive?
No, it's not going to change this. It's not going to, negative powers don't change signs. What do?
Make
Makes it a fraction, right? So this guy would go to the bottom.
So positive 1/3?
So it would be O over, no, it'd still be negative 1/3, but it would be positive 1 down there, power, which is just 1 over negative 3. The other way is using the quotient rule. Quotient says find the limit of the top, find the limit of the bottom, and divide it. So the limit of the top doesn't have an f of x or g of x or h of x, right? It's just a 1. So guess what the limit as x approaches a for 1 is going to be? Just 1. And then what's the answer? What's the answer to f of x again? Negative 3, right? You do it that way too.
Can't you just plug it in f of x? Probably log 0.
Yeah, either way, doesn't matter. You can use the power or you can use division. Either way will give you the same answer, negative 1/3. All right. Okay, so now let's go to the second part. So now they give us new limits. For f of x is negative 3, that one stays. For g of x is 0, oh, it's the same, right? Yeah, 0 and 8, yeah. So they don't change the limits, but they're just giving us different problems. So the first one is division, right? So let's go back up to where it says division. Quotient. The rule says find the limit for f of x, find the limit for g of x, and then divide them, as long as the bottom limit is not 0. So let's hope the bottom limit's not 0. Okay. So we get the limit. Oops, I went too far. The limit as x approaches a for f of x on top, and the limit as x approaches a for h of x on bottom.
Can't we just plug in the numbers like that?
Yeah, exactly. That's what we're going to do. We're just going to plug in numbers, right? Since it's your notes, I'm writing it out a little bit. But if you saw this question on a test, yeah, you would just go right to plugging in numbers.
Negative 3 and positive 8?
Negative 3 over positive 8.
Can that get broken down, or is that just the answer?
That's the answer. Yeah, we can't reduce it, so it's done.
For f, the
So the limit as g approaches, or as x approaches a for g of x is 0, right? What's the limit as x approaches a for f of x? Negative 3. Well, if you have 0 on top, it's always going to be 0. Unless you have 0 on bottom, which I don't. So what about g?
the limit is reduced
Exactly, because why would this one be d and e?
because 0 is on the bottom.
Yeah, because top would get negative 3, right? Bottom is 0. Anytime that happens with a limit, it's d and e. It's d and e. H is kind of one they like to do on free response tests. They like to do that because it mixes, right? Which properties do we have for letter H?
Difference.
We have difference on the bottom, quotient, and we have a scalar. We haven't used scalar yet. The 2 in the front is a scalar. Okay? So I'm going to rewrite this one. Okay. So it's 2 times whatever I get on top, right? So it's the limit as x approaches a for f of x. So whatever I get for that, I'm going to multiply it times 2. That's what the scalar property says. Just multiply. Scalar means multiplying. Okay. On bottom, I have difference. So subtract. So I'm going to do the limit as x approaches a for h of x minus the limit as x approaches a for f of x. Okay. So the top. F of x is negative 3, so you're going to have 2 times negative 3 on top. On bottom for H, you get 8. G or F, you get -3, right? So it's going to be 8 minus a -3.
Which cancel out to make positive. No?
Yeah, so so double negatives, it's going to be positive, positive. So you're going to get -6 over positive 11. So you can combine properties too. It's not just always going to be one property. It could be different properties. That one had 3 properties in one question. Okay. All right, so that's that way. So the back is graphs. So now they could also give you the function as a graph. Okay. So if you look at A, B, and C, they look the same as they did on the front, right? So A, the limit as x approaches 2 for F, plus the limit as x approaches 2 for G, right? That's how we're going to solve it. They don't tell us the answer, so we got to look at the graph. So go look at the graph. What is the limit as x approaches 2 for F?
2?
So 2 is right here, right?
Yeah.
So as I come from this side, what y value am I approaching? 2. As I come from the other side, what y value am I approaching?
2.
So the limit is 2. Now also for 2, but at the other guy.
0?
So it's up here, and then I come down here. I'm at 0 y value, right? Y value is 0. Same thing here. I'm also approaching the y value of 0, right? Because the limit's there. So that would be 0. So we would get positive 2. So it's kind of a combination of what we did earlier in the chapter when you were finding limits of graphs. The first thing we did this chapter was find limit of a graph. Okay? So B, we have the 2 in front and the 3 in front. So you're still subtraction. So this is what we're doing. We're going 2 times the limit as x approaches 1 for f of x minus 3 times the limit as x approaches 1 for g of x. That's really what that says. 2 times your limit of 1, f of x at 1, and then minus 3 times the limit of g. So we got to find the limit at 1. So the limit at 1, so 1's right here. So the limit as I approach this side and as I approach that side is the same guy, positive 1. So it's going to be 2 times 1.
And then for G is also 1, or is that going to be?
So let's see. Yeah, so let's see. 3 times the limit at 1, right? So let's see. The limit as x approaches 1 is positive 2 there, but it's positive 1 there. So that's d and e, right?
Oh, that makes sense. How can you like?
So how do you multiply times a d and e? You can't. So the whole thing is just d and e. Yeah, you can't multiply times a d and e. Just like you can't multiply times an undefined number. It's just undefined. In this case, it's a limit, so it's d and e. Okay, so letter C. The limit as x approaches 0, so we're going to go f of x times the limit as x approaches 0 for g of x. So the limit as x approaches 0 for f is 0, y equals 0. And the other ones we're going to have to guesstimate. Yeah, the other one we're going to have to guesstimate because it's, I've noticed that it's,
1.5?
yeah,
But
probably.
times 0 is 0, so you don't really need to.
There you go, right? In the end, It's moot because anything you multiply times 0, 0. So I would say the y value is like 1.5. I think 1.5 is a good estimate there. But anything times 0 is just 0. Okay. So that's how you do it for a graph. That's how you do it for a graph. Same thing, same properties. It's just you got to look at the graph for the limit. Okay. All right. Now what I want you to do is I want you to do D and E. Since we've done D and E, I want you to do D and E. It's the same graph, same F and same G. F we'll do together because F is a little different.
What are we supposed to do with the x to the third power? Is x going to be just 2 or?
Good question. So it's going to be multiplication, right? So it's going to be, let me write this. It's going to be the limit as x approaches 2. This is x cubed times
2?
the limit as x approaches 2 for f of x. So that's really what it is.
So then what do we do if the bottom is 0? Do we just put D and E? Like,
Yeah. The bottom is 0, D and E.
Okay, thank you.
Yeah, so D, the limit at -1 is -1 for f. For G, the limit at -1 is 0. So you have -1 over 0 again, right? So that's D and E. Because the limit,
Why did the x cubed get its own thing?
where was it? Here and here. Say what?
So why did x cubed?
Because it's multiplication.
So then
It's the limit of everything. So it's the limit because there was multiplication here. So it doesn't matter. I'm not going to use the graph for that guy. It doesn't matter. You would just, so I got to find the limit of that guy. So how would I find the limit for this guy here?
which, oh, it would just be 2 cubed.
Yeah, plug it in, right? Just like we've done doing, plug it in. So it would be 2 cubed times, and then the limit at 2 for f
2.
is positive 2. So you get 2 times 2 times 2 times 2.
And that just be
16.
4?
Yeah, 2 to the 4th, yeah, 16. Okay. F is what we call a composition of functions. G is inside of F. G is inside of F. Okay? So in math, so let me expand on this one a little bit. So G is inside of the function f. That's why it's called composition, one inside of another. So in math, when we have parentheses, where do we always start? On the inside, right? We start on the inside. So I'm going to start with G. So how I'm going to do this is I'm going to find the limit
Is it approaches 1 from the left side?
from the left side for G of x. That's the first thing I'm going to do, the inside. Do the inside first.
That's 2?
Inside first. I'm not worried about f yet. So what is the limit from the left as x approaches positive 1?
2?
Positive 2. It's going to be positive 2, right? Positive 2 because it's only coming from this side. When x approaches 1, it's going to be, the y value is going to be 2.
Negative, I thought it was a
Okay. So this guy is 2, right? Whatever answer I get, I'm going to plug back in. I've already done the limit, so I don't got to do the limit again. So it's going to be f of 2. No more limit, because the limit has already been found.
Which is 1?
So f of 2 is positive 1, because that's where the dot is, right? F of 2 is right here. So it would be positive 1. So the answer to the whole thing is positive 1. Let me give you another one like that. I want to give you another one like that. Even though they didn't have one like that, I want to give you another one like that. Let's see. Let's do that one. So let's do, this is letter H. So the limit as x approaches, let's say, positive 2.
Where does F move to?
And let's do f of g of x.
Where's it move?
Zero?
So let's see. I haven't done it yet. So let's see. So we're going to find the limit as x approaches the inside. So the limit as x approaches 2 for g of x is 0, right?
Can't you just do like the math of this? Like, you gotta really write it down.
Yeah, if you're looking at a graph especially, for sure.
I'm explaining it. You have to first.
Or like for the test,
Zero.
you can actually write it down.
You just have to tell me what you're finding. So like this. So then, so the answer to that is 0, right? The limit as x approaches 2 for g of x is 0. What is f of 0? 0. Sometimes they'll do like g of x. So sometimes they'll do something like this. Watch, let me write it down somewhere. They'll do like g of x. The limit as x approaches, I don't know, 2 again. So then you'd go the limit as x approaches 2 for g of x,
Which is 1.5.
and then you find g of 1.5. G of 1.5 would be like somewhere right here. Yeah, something like that. Okay? That's also a possibility. That's all you do. You just find the limit of the inside, plug it back in, and then f or g or whatever. Okay? Last one. Last one, then we're done with this. And then I'll let you guys work on the practice. Okay, so we have this guy. The limit as x approaches 1 for f(x plus 2). How do we do that guy? So if we plug it in, so if we plug in 1, right, we're going to get f of 3, right?
Which is DD. Well, because it's a whole at -1.
Yeah. So the way I would do it is since it's a plus, right? Let's separate it. Let's use the sum rule. So the limit as x approaches 1 for f of x plus the limit as x approaches 1 for 2.
Oh god. It's -3. Oh yeah, so it is negative.
So that's it, yeah. So if you, so let's see, the limit as x approaches 1 for f of x is -3, right? -3 right there.
So even if there's a hole in the actual spot, it doesn't really matter.
Yeah, for a limit, it doesn't matter. And then what is the limit as x approaches 1 for 2?
2.
Just 2, yeah, because look at, I can't plug in 1 anywhere, right? It's always going to be 2. That's one way to do it. The other way to do it is, like Jonathan said, plug in 1. You could have plugged in 1 from the very beginning, and it would have been f of 3, right? But then you would need to find the limit there, right? You would need to find the limit there, and that would be -1 as well at 3. I think it's easier to do it this way, to separate them and then do 2 small problems, but the other way actually works. The other way also works.
Will it work all the time or no?
Should work all the time. Should. But like I said, this is the method I would prefer to use because I'd rather do 2 smaller problems than have to worry about that. But again, it works. Okay? That's it. That's properties. It's just practicing using the properties, okay? So what I want you to do, we got about 20-something minutes. Two things. First thing, work on practice 5, which is the one I showed you. It'll go really fast, just like this one went really fast. If you finish, work on any of the practices you haven't finished, okay? One thing before you, or while you're working, on Google Classroom, I put that we have a quiz